Using formulas to write equations for lines. In this video, we're going to write equations for lines given the slope and y-intercept, given a point in the slope by using the point-slope formula, given the point and the slope of a line parallel, and given 2 points using the formula for slope. Our first example, we're asked to write an equation in slope-intercept form for the line through the point 0, 2 with slope -1. Well, slope-intercept form is the form y equals m, the slope, times x, plus b, the y-intercept. I need to fill in m and b. And m, I see, is this slope -1, so I'm going to write -1 there. Now how about b? Well, the point 0, 2 is a y-intercept. When x is 0, y is 2. And if I need to, I can even sketch a little graph just to verify that the point 0, 2 is on the y-axis. So b is 2, and I filled in m and b in the equation. And now I can write the equation y equals -x plus 2. In my next example, I'm asked to write an equation in slope-intercept form for the line through the point 4, -3, with slope 1/2. Well, I want to end up with slope-intercept form, but if I have one point and a slope, I can use a form called point-slope form. Point-slope form says that y minus the y-coordinate of the point is equal to the slope times x minus the x-coordinate of the point. Well, let's fill in the values we know. The x-coordinate of my point, x1, is 4. So I can fill in 4 where it says x1. The y-coordinate of my point, -3, can be filled in the y1 spot, and the slope I'm given to be 1/2, so I'll fill that in for m. Now it's just a matter of simplifying this equation. Y minus -3 is the same as y plus 3. Equals 1/2 times x minus 1/2 times 4. So y plus 3 is equal to 1/2 x minus, well, half of 4 is 2. So 1/2 x minus 2. To get it into slope-intercept form, then all I need to do is solve for y, so I'll subtract 3 from each side. And now I have y equals 1/2 x minus 5. That's the equation for the line we're looking for. I've graphed 3 lines with the same slope. They each have slope 2, and you can see that they're all parallel. Here's 3 more lines with the same slope. All these lines have slope -1/2. They just go through the y-axis at different points. So lines with the same slope are parallel, and vice versa. Parallel lines have the same slope. We're going to use that in the next example. So the third example says write an equation in slope-intercept form for the line parallel to the line y equal 3x minus 7 and including the point -1, 4. Now, in order to use the point-slope form, I need to know the point and the slope. Instead of giving me the slope directly, this example asks me to find a slope that's parallel to the slope of the line y equal 3x minus 7. But that line is in slope-intercept form. Y equal 3x minus 7 has slope m equal 3. And so, since parallel lines have the same slope, that's going to be the slope I use to write the equation for my line that goes through -1, 4. All I wanted from this equation was the slope. this isn't the equation that we're looking for. These are not the equations you're looking for. But if I use the point -1, 4 in the formula, I can fill in y equal 4, m equal 3, since that will be parallel to the line we were given, and x equal -1. So once again, I just need to simplify the equation to get it into slope-intercept form. Y minus 4 equals 3 times x minus a -1 is the same as x plus 1. So y minus 4 equals 3x plus 3. And to get y alone, I add 4 to each side. And so I have y equal 3x plus 7. So that would be parallel to the line that goes through 0, -7, but it's going to go through 0, +7 instead. If I'm given 2 points on a line, I can always find the slope by graphing them and counting. The run in this case is 1, 2, 3, 4. So I have a run of 4 and a rise of -1. So that gives me a slope of -1/4. But if I just have the numbers and I don't have the picture, I can figure it out by noticing that the run is the difference between the two x coordinates. The difference between -1 and 3 is 4. And the rise is the difference between the two y coordinates. The difference between 3 and 2 here is 1, and it's a negative because it's going down from 3 to 2. That gives us a formula that says the slope is equal to the difference of the y-coordinates of the 2 points I'm given over the difference of the x-coordinates. I'm going to use that in the next example. Write an equation in slope-intercept form for the line through the points -2, 4, and 1, 1. Well, let's collect our information. When the first point, -2, 4, has its x-coordinate, it's going to be called x1, and its y-coordinate will be called y1. And the second point has coordinates x2, y2. Now we'll use these to find the slope. We find the rise by subtracting the two y-coordinates. So y2 is 1 and y1 is 4. And then we find the run by subtracting the x-coordinates. x2 is 1 and x1 is -2. When I simplify, I have that the slope is equal to 1 minus 4 over 1 minus -2, or 1 plus 2. That's -3 over 3, and that's equal to -1. So I've discovered that I have the slope equal to -1. Now I can use point-slope form. And even though point-slope form says x1 and y1, I can choose either point, and I'll get the same answer in slope-intercept form either way. So m is -1, x1 is -2, and y1 is 4. Now I can simplify. Y minus 4 equals -1 times x plus 2. If I distribute -1, I get -x minus 2, and then I add 4 to each side to get y alone. And y equal -x, -2 plus 4 is +2. So I've found the equation of the line just given 2 points. Step 1 was to find the slope, and step 2 was to use the point-slope form to find the equation.